In the Advanced Habitat Survey, we establish a permanent benchmark and conduct a habitat assessment. The first thing we want to do with the, in Module 2, the Advanced Survey, is establish a benchmark location. In other words, we're going to mark our reference site so that we can come back to it year after year. What we want to do is permanently mark some feature in the reference section of stream and tie that into preferably a man-made structure that we know is going to be here in years to come. There's a number of ways of marking them. We're going to use just, in this case, aluminum tags.
Survey tag?
Yeah.
Okay.
They don't stand out.
Well,
They're not as conspicuous.
Okay, so I'm not going to nail this in, but I'd want to get this up as high as possible. So we've got an aluminum tag with a nail, and you can use a scribe, which I have here in my pocket, and you would basically write the sample location on there, the benchmark location.
And what's important is whatever you write on there, you also remember to write on your data forms.
And you just nail it into the tree like that, maybe up as high as you can go.
Yeah.
And then again on that tree on the other side of the stream.
Okay, and so this now becomes our reference point for this module and future modules. Okay, this section of stream now that we've referenced by marking this tree and tying into some other structure is going to become the section of stream that we survey in detail. Okay.
So this is so we'll relate all our water quality sampling,
everything,
our bug sampling, our fish sampling will all be related to
this point.
This benchmark.
This point.
Okay.
Okay.
Great.
So yes, I'm just going to head from here. I'll head across the stream, and what we'll do is we're going to follow through Module 2, which starts to quantify the habitat. We've selected the site because it's a representative section of stream. So in theory, this section represents the stream a quarter mile upstream, perhaps a quarter mile downstream. At this point, we'll start quantifying available habitat and stream features.
Okay.
Okay?
Yep.
Okay, so now, Module 2, the Advanced Stream Habitat Survey, the first thing we're going to do now that we've established a benchmark is cross-sectional survey. So the process here is the same as we did in Module 1. We're going to measure bankful width, channel width. The only difference is at this point now we're going to measure the average bankful depth and the average wetted depth. We're also going to draw a cross-sectional, a picture, a diagram of the cross-sectional profile here. So we'll start by measuring bankful width, cutthroat fry. And again, what we're looking for is the scour lines or the lines of perennial vegetation. So, bankful is about 5.2 meters. Where you've marked bankful on this side, it's also approximate water's edge. Okay. So we can also measure the wetted from this point. And the wetted channel width in this case is about 3.2 meters. So again, I'm going to measure the average bankful depth, and in this case we can do the wetted depth at the same time. Starting at the point 1, I'm going to move in a half a meter and make two measurements. One, bankful depth. In this case, it's approximately 60 centimeters to bankful, and 10 wetted. And I will do it again. 60 again is bankful. 8 in this case is wetted, and so on and so forth, all the way across every half meter. We're starting to drop now. 55 and 5. Okay, and we do that across. And we'll average those, and that'll give us our average bankful. 60 and 6. Okay?
Okay.
So you make a note of that, and then the next thing you'll do is facing downstream, same orientation we used before. You'll draw a cross-sectional profile. And again, that gives us some indication. If we use this as our reference site in the future, we can document any bank changes that occur.
It's also probably a good idea to take some photos.
It's nice if you can, not just with the tape, the same way we photograph the the stream features downstream with the whiteboard and the description. The same thing here. Somebody in the picture, or if you can't put somebody in the picture, the whiteboard, piece of paper, chalkboard, whatever it is, with the description, the habitat, pardon me, the benchmark location on that whiteboard, so that when you get pictures back, you know where they were taken. What we're going to do now is we're going to measure stream discharge. The important thing in measuring stream discharge is the selection and location that we're going to measure it. What we want to do is make sure we've got a nice straight run, one main channel. If need be, move some rocks around a bit, just so we've got a nice clear run. The process here is to take the wetted width of the stream and to break it up into 5 panels. Okay, and to try and measure the velocity in each of those 5 panels. So what we're going to do in this case, we've got a stream width here, wetted width of approximately a meter. We would break that up into 5 panels, so 0.2 of a meter, and we would measure the velocity in each of those panels and then take the average. So the way we're going to do that is the stream keepers kits most of them come equipped with tennis balls. In streams that aren't quite as shallow as this one, you could use oranges. Sponge rubber balls will work as well. We've paced off, because it's a small stream, we've paced off a 5-meter long section. And what we're telling you is that between a 5 and 10-meter stretch of stream should be used, straight run. And the idea is that you clock the tennis ball from the start point to the end point. So we want to know how fast it's going. And from that, from that velocity, we will then use the cross-sectional area and calculate total discharge. Start right now. So you're timing it.
Okay, you got it. 20 seconds.
20 seconds. So 5 meters. Took 20 seconds to go 5 meters.
Yeah.
All right, we would repeat that 4 more times, keeping in mind that we've broken the stream up here into 5 panels. The way we calculate discharge is outlined in the manual. Okay, so now we're going to do the longitudinal profile. With our using our benchmark, okay, what we're going to do now is we're going to sample a section of the stream 12 times the bankful. Benchmark location's in the center, which means we're going to start downstream 6 times the bankful. You measured the bankful earlier. It was 5 meters. 6 times is 30. So we're going to go downstream 30 meters, and at that point we're going to start a longitudinal profile. We'll just work back upstream. Okay, so we'll do that. So we've now come 6 times the bankful. So we've moved 30 meters downstream. We're going to mark this location. This is going to be the beginning, or the downstream end, in this case, of our longitudinal profile. Okay. So again, for our reference, I will flag it. At the end of the day, we'll come back and pick up our flagging. Okay. Now what we're going to do is we're going to run a profile, a longitudinal profile, meaning we're going to work our way upstream. Okay. We're going to measure each habitat unit. Now there's only 2 discrete types of habitat we're dealing with: pool and riffle. Okay, pools, almost flat, 0 gradient, fairly deep standing water. Okay, and then riffle, where we've got a more noticeable change in gradient, higher velocities and shallow depth. What we've done is we've taken the stick, right, and I've wrapped a piece of flagging tape at my eye level. That's going to be my target. So we're going to stand at water's edge. You're going to stand at the top of the unit. I'm going to stand at the bottom, and I'm going to sight using the clinometer on this piece of tape. Off the clinometer, I can read the percent slope directly.
Okay.
Okay. So go for it. Wait a minute. We're all tangled here.
8 meters, and I've got the survey stake right at water level.
All right. You're at water level. 8 meters. And I am now looking at a slope of less than 1%. In this case, the gradient measured is 5%. Okay, so this has a 5% slope to it. And we continue. So we do this now until we've completed that reference section of 12 times the bankful. Okay. And we make sure that we record each pool, riffle length, and the slope as we go. In addition to that, what we want to do This is representative habitat, is we would take a picture of a representative pool, representative riffle, okay, to document the type of habitat in our reference section. So we've now we've completed the longitudinal profile. We're now going to start quantifying the types of specific habitat, substrates, those sorts of things in this section of stream. The first thing we're going to start with is doing a stream bed material, or collecting a sample of stream bed material. We want to do this in both a riffle and a pool. And what we want to do is collect a random sample of 25 particles. Okay. The data sheet has it broken down into categories based on average diameters. So what we're going to do is you're going to go out and you're going to collect 25 random samples. And the way you're going to do that is you're going to set up a pattern, basically of walking through the stream channel.
First step in, pick up what's at the end of my boot. I need the ruler. Okay, we've got 6 by 8.5 by 2.2. Drop that one down, take another step. Pick up what's at the end of my toe. It's a little one this time. It's 1.3 by 1.8 by 0.6. And I just carry on and do this for 50 or so samples, right? Yep. Okay, so I just continue this process across the stream. Obviously, I'll get to the other side of the stream before I've picked up 50 rocks.
Yep.
So I would just toss the rock downstream and start the same transect back again. That's and continue that back and forth until I've got 50.
Yeah.
Right? Okay.
And just keep the same pattern. So it's the same random process that you established at the beginning. Make sure you maintain that. Okay, so you've now got your sample, 25 to 100, or pardon me, 25 to 50. You've written those down. The next thing to do is to look at the substrate and determine the percent of embeddedness. Okay, this is simply picking an area where there's a number of larger rocks and lifting one out to see how much of it's actually buried with fines. Okay, so you're estimating what percentage is buried in the fine material surrounding it.
Okay.
So in that case, all we'll do is pick a nice spot here.
So let's grab some of these here in the riffle area. Okay. So that was, you can see actually the stain line on it where it was the part that was above water and the part that was below.
Yeah, okay.
And there's the stain line right there. And that looks like it's pretty close to 50% embedded. About half of it was in the substrate and half out.
All right.
On that one.
So you do a couple more and try and get an average.
This one was much less embedded. There's the line there. I'd say that's probably closer to about 25% embedded.
Okay. So all you're doing is running your hand. You're selecting a boulder, or a rock. You're running your hand down as far down the rock until you meet the fines surrounding it, and that's you're marking the rock using your fingers and lifting it out.
Yep.
Yeah. Okay. So you make note of that. Do a number of samples and take the average.
Okay.
All right. So you've now looked at the substrate.
Yep. We got stream bed material. We got percent embeddedness.
Okay. So now we start to look at some of the other physical stream, the cover features. Okay. And what we're going to look at now is a number of pieces of what's called large woody debris. Okay, and that's these large logs. Anything over 10 centimeters in diameter.
Okay, so this is a good piece right here.
And it has to be, and it should be within the bank full width of the stream. Okay, what has to be remembered is that even though it's high and dry right now, like this tree here, although it's living, it's still within the bankful, so it provides cover, large woody debris and habitat during high water conditions. Okay.
Okay.
So now within our study section, we're going to go back over it, and we're going to count the number of pieces of large woody debris. all right?
So this is the total number and that 12 times the bankfill channel width, the longitudinal profile.
Yeah.
Okay.
Okay, so we're just gonna, that's our sample, that's our reference, or our sample section,
Okay.
right? Our representative sample.
Yeah.
So we'll go back down, it's 60 meters of stream. We'll go back down and count the number of pieces of large woody debris.
Okay.
In addition to that, what we're looking for is the number of cut banks that we find as well, rooted cut banks. So those are cut
something like
banks
this over here?
are solid. Those are,
Like this
that's a
one
good
here.
example. Yeah.
That goes back probably, well, let's see, that looks like almost 20 centimeters.
Okay.
So that's rooted, it's very stable, it's undercut probably 20 centimeters.
Yep. Okay, so we'll
And that's
document
good
those
rearing
as well.
habitat as well.
So we're just going to record those. Total number of pieces of large woody debris now, and the total number of rooted cut banks. Okay, we're going to finish the habitat quality portion of Module 2. Basically, the last 5 items we can either calculate or, again, simply enumerate. So percent pool habitat and the slope of the survey site, we can derive that from our earlier longitudinal profile. Off-channel habitat, if present or not. So in this case, we just want to describe it. And there's off-channel habitat upstream, so we would describe
So
the
this
type.
little channel coming in
Yeah.
from the off into the main channel here.
So we would document that. We
So
describe
we'd measure
it.
the length of it and the dimensions. And, okay.
Okay. We're interested in bank stability. Okay, again, looking downstream, left and right bank, we would make note within our sample section any bank stability problems. And this looks fine. I mean, it's stable. It's well rooted. It's held in place.
So we're looking for raw slopes where there's active erosion.
That's right. So
doesn't look like there's any of that here.
you know, and if there is a bit, it's not. I mean, most of it's probably natural. So. Length of banks, no vegetation. Again, not a problem here. The banks are heavily vegetated. The overhead canopy, again, if you look at the riparian and you look up, there's pretty good overhead. The canopy is pretty thick and pretty well intact.
So here we're estimating the percent of the channel that's covered over by
The idea is
vegetation.
that if you look up how much blue, in this case, it's a nice sunny day, how much blue can we see? So if you figure, sample area of 100%, how much blue can we see? Well, it's pretty
Well, it's
well.
almost 100%, isn't it? The branches
it's
pretty well
getting there.
come all the way across.
It's getting there. So it's, I'd probably say 75%. Okay, and then the last is trying to qualify and quantify a bit of, or describe a bit of the riparian zone, and that's basically the vegetated zones that parallel the stream. So in this case, we're looking at the riparian zone, and we describe it in terms of the number of channel width. So our channel width was 5 meters.
Right.
Well, this is wider than well, what? We're probably looking at riparian zones of 10 times the channel width. So it's very healthy riparian.
So it's an eyeball estimate.
Basically, yeah.
Okay.
I mean, there's nothing stopping you from measuring. Perhaps if it was a narrow riparian, you might actually want to document the exact
Measure,
width.
so you'd walk back with the tape.
With the tape.
Yeah.
From, and the bank, or the measurement for that starts at the top of the bank, back.
Okay.
Okay? And that's it, okay? We've now basically, you've assessed all of the streamside, or pardon me, the stream habitat. You've assessed the habitat quality in this reference section. We will now take all that information, we go back, and what we do, the last step of the process is we score the habitat. Okay, so the last page, the data sheet, where we determine whether or not this habitat is good, acceptable, marginal, or poor, is we go back through all those parameters and the values that we've calculated or found, and we score each of them. We add up the score and we come up with a rating. And that'll give us some idea. My guess is it's going to be
This is going to be pretty good.
Yeah.
Looks good.
All right.
Okay.
So that's it for Module 2.
Great.